took them out whenever I did my homework, and I felt like putting them back.
So I believe I was telling you when you left that this is a type of function called a logistic function. And what it does, it's a really interesting function. At first, it grows like it's exponential, right? Like e to the x or something like that. And then at some point, it decides, I'm going to level off. And what you have up here is this sort of imaginary line, this asymptote, that is the carrying capacity, the most that can ever happen. So, Lily, you're asking about, is this the way that viruses actually spread? Yes. It's also the way populations grow. If you put enough animals to be, have enough genetic variability, you can't have, just two and expect it to work for long term. But if you populate an area where they have enough food and they have enough water and all that kind of stuff, at first the population will grow exponentially. Eventually it will slow down as they start to run out of things that they need, usually enough food to eat. Okay? And that's the way populations actually tend to grow. They grow exponentially while there's lots of food and water and space. And then once there's not as much, it tails off until they reach this carrying capacity. Now, what actually happens is a little more interesting than that. In the wild, at least, what will happen is this comes up to this and it actually goes past it, and then it goes below it, and then it goes past it, and it becomes almost sinusoidal.
Wait, why don't they die if they're out of food?
Well, what happens is when they get above this line, they start to die off.
Right.
And then when they get below the line, then they start to repopulate.
But they repopulate on what food?
Oh, well, we're not saying all the food disappeared entirely.
Oh.
We're saying
it's like limited resources.
It's like there's not enough food for everybody.
Okay.
So Charlie had to die. It's just kind of the way it goes.
Sound good.
You know?
Charlie in the Chocolate Factory?
No.
He didn't have much money.
Lily's reaction to getting in trouble is, aren't I cute, isn't it? All right. So we want to know, when will the flu spread at its maximum rate and what will the rate be? So we need to find the rate, and that would be the derivative, p prime of t. And you would probably, we could leave this as a quotient and do the quotient rule, but I would probably rewrite this as 100 times 1 minus e to the 3 minus t power to the negative 1 power. So then the derivative will be negative 100 times 1 minus e to the 3 minus t to the negative 2. Plus, thank you. Times the derivative of 1 plus e to the 3 minus t. Now let's see, the derivative of the 1 would be 0. The derivative of e to the negative to the 3 minus t would be e to the 3 minus t times the derivative of 3 minus t, which would be negative 1. That negative 1 turns out to be important because otherwise our derivative would be negative. And I think you can see pretty clearly here the derivative is always positive for a logistic curve like that. So this would be, if I rewrite it more simply, 100 times e to the 3 minus t over 1 plus e to the 3 minus t squared. And I want to find, where does that have a maximum? Okay. Now, we haven't studied this yet. We will later. So for now, we're just going to use a calculator to approximate when this happens. But later on, we'll look at the way we can find it is by taking the derivative of that and finding where it's equal to 0 or doesn't exist, because those are places where you could have a maximum. But for purposes of this discussion, we'll just grab a calculator, slap it around until it wakes up.
Excuse you.
We'll graph this, clearing out any other stuff that's in the way. And since this is complicated enough, although I know Irfan loves to use parentheses for everything. No, he's like, I much prefer to use, nested parentheses, and I'm like, ick.
He doesn't like the fraction part.
He does not.
Honestly, it wasn't for you.
You didn't read your notes.
Oh, I didn't? I didn't know I had anything on it.
So this would be 1 plus e raised to the 3 minus 2. Oh, and I need to put that in parentheses.
Adding parentheses after you.
How do you rate that joke?
How you do what?
Whoa.
You just insert them.
Ah.
That's 3 minus t, right?
It's not 3 minus 2.
Oh, 3 minus t. Thank you.
R. Or X.
You put that on your wall.
So weird.
She's clapping back.
So if I try to do this in a Zoom standard, I don't think I'm going to see anything. Oh, there is something.
She's not. Why is it
Oh.
negative? Oh.
Oh, well, we can't see the top, can we?
Well,
No. That's not very helpful.
No, it's not. Well, for all we know, it cuts off right there.
Yeah.
Yeah, maybe
No,
there's
this
no
is a
problem.
continuous function. I
No,
know
maybe
that it
there's
doesn't
no
cut off right there.
Yeah.
Thank you for playing. We have some lovely partying gifts for you. So, I could try to adjust the window.
100.
That's a little bit much.
100 seems like overkill.
Maybe like
70.
50?
75.
75.
Yeah, 75. Come on now.
27.
I disagree.
Woo!
No.
We only need to
Oh,
do
and 50
30.
was really more than we needed.
It's really disappointing. Yeah, it is. I wanted it to be bigger. I wanted it to have big fun now.
So I want to find that high point. Oh yeah, I can use maximum on here. You guys ever used that before?
Yes.
I like algebra. I know very little about my calculator.
I just want to learn that.
Thanks.
So it's somewhere between 0 and, I don't know, 6.
On a roll. You made a really good joke in government today. You wouldn't appreciate it. I'm so upset.
What was it?
When Macy was upset
Oh,
about
that
her
one?
cowboy boots, you were like, you know what, you're right, because you're the center of attention and everybody's going to be looking at you and you ruined it because now you don't have the right outfit.
She was like, yeah.
So this is t is equal to 3, and the rate is going to be 25, what was it, students per day.
Studs.
Stud muffins.
I hate that
Well, I didn't.
One of the
So-
interesting things,
class.
if we were to substitute back into the original, P of 3 would be 100 over 1 plus e to the 3 minus 3. That'd be 100 over 1 plus e to the 0, which is 1. That's 50.
That's not right.
I think I told you yesterday that 100 was going to be the number of students who would catch it. When you get halfway, and it makes sense, then you have fewer to catch it, so it starts to slow down.
Huh.
Yeah, I remember the first time I saw a logistic function and someone explained all this stuff to me, and there's more to learn about it. We will later on in this class. I was like, that is the coolest function ever.
I can tell you're enthused.
Seriously. Because, like, you know, things don't grow exponentially forever,
It's true.
right? Nor do they, most things don't really grow linearly either. So, anyway, it was just interesting because that is how populations grow. When they get over halfway to the carrying capacity, it starts to slow down. All right, so let's do today's lesson. Why is this in a separate window? I don't know. I don't think I did that.
Capacity in the other window.
Maybe.
Got him.
Good blackface, how cute.
So we are starting chapter 5 in today's notes. We'll be taking our test on chapter 4, I believe next week. But Lynn knows the calendar better than I do, so. Do you have a quiz Monday?
That's what Lynn says. Oh, that quiz today.
We do have a quiz today.
Yay!
We also have one Monday, apparently.
Oh.
Really? Say it. Say it. No. Who says that?
Okay,
You? Do you say that?
He's
Probably at some point.
so today we're going to talk about extreme values of functions. So, let f be a function with domain capital D. F of c is the absolute maximum value of f on D if and only if f of c is greater than or equal to f of x for all x in D.
There's a guy struggling to carry a box through the door. He like dropped it.
Mr.
Is
Ingram.
that That's Boot Boy. No one wants in the box. Please.
And why is it him?
I could sit around and watch other people work all day
Maybe
long.
it's heavy. Oh, he's
Oh,
trying.
he's trying.
Wait, what's it say? What's it say?
It says SA.
There's handles, man.
There are.
Bruh.
All right.
Some
So, back to the calculus.
Sports.
Oh, there we go.
There we go.
Yeah.
Savior.
It's like, whoa, third person.
He timed it just in time to get there to not help.
What's her?
Actually, he probably will help him
Yeah,
get
get
it
it
up
in
into
the
the
truck.
truck.
Oh, that would have been
Skip
funny.
to the next
It's an awkward hangout.
It's awkward and heavy.
Are they gonna like high five each other?
No.
Nope, didn't even say anything.
They're not like Northland.
All right.
Yeah, they're not-
So,
they don't know bro.
again, f of c is the absolute maximum value of f on D if and only if f of c is greater than or equal to f of x for all x in D. F of c is the absolute minimum value of f on D if and only if f of c is less than or equal to f of x for all x in D.
It's a lot of X's and D's.
Yeah.
And C.
Yeah, so basically, is it the highest point or not? And there can be ties. The highest point can occur, like for example, think about the graph of y equals sine of x, right? What is the maximum value?
One.
1. Does it happen more than once?
Yes.
Yeah.
Yes, it does. So the maximum can happen more than once. You could have a tie for first, as it were. Okay? Same for the minimum for sine and for cosine. Okay? For this particular one, if this is our graph of y equals f of x, the absolute minimum on this is 0. which occurs at x equals 0. The absolute maximum is f of c. One thing to point out is that the maximum or minimum value is the y value, not the x value. Okay, the x value is where did it occur. Okay, your book is not always the best about saying what they want. So in most cases, you can cover your bases by saying the maximum is 5, which occurs at x equals 3. And then you've totally covered your bases. You've said both where it occurs and what the maximum is. Or if you want to even say, the maximum is f of 3, which is 5. That tells you both where it occurs and what the value is. Okay, and you can do that on the AP exam too. I've seen a lot of students do that. They make sure they're like, Derek, I'm going to say everything that I know about this. But if you say the maximum is x equals 3, no, that's completely and totally wrong. Okay? So your book says absolute. Some texts say global, and you'll occasionally see that on an AP exam as well, the global maximum or the global minimum. Okay? A lot of times in problems, they don't even say either. They just say the maximum or the minimum. Okay? It means the same thing. So you don't have to necessarily say the absolute maximum or the absolute minimum. Notice there's no calculus in here anywhere. Okay? This is a non-calculus thing. It's like this little flock of 6th graders or something. All right, so if no interval is specified, it's understood to mean that the interval is the domain of the function. And that happens a lot. All right, if there's a natural domain for the function and they don't specify an interval, then it's the entire domain. So here's a question for you. Must every function have a min and max on its domain?
Yes. Oh no, if it's a straight.
Pardon?
Yes. No.
If I stare at her long enough, she'll change her mind again.
It's a no from me.
Why?
Because it could be like a straight line.
All lines are straight. You knew I was going to say that.
Sorry. It goes on forever. There's an infinite
You
line.
mean a horizontal
Yeah,
line?
yeah, that's what I mean.
Okay. A horizontal
I
line
guess it
has
does have a min and a max.
it has a minimum and a maximum. They're both the same.
Well, what if it goes on forever?
That minimum and maximum occurs an infinite number of times.
Okay, fine, yes.
If you say so.
Whatever you say the right answer is.
Well, let's see if we can answer this. So we already answered this. What's the maximum value of y equals sine of x?
1.
1. Does it occur more than once?
Yes.
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 Of course.
Page the next. So let's look at this first graph. Does this have a minimum?
Yeah.
No.
What is the minimum?
Whatever
Whenever
is
x equals a.
So that's f of a. Does it have a maximum?
Of course. Just don't really know what it is.
There is no maximum.
Oh.
Why not?
Well, what would it be? It's not f of b because f of b doesn't exist.
It'd be the limit.
Well, like, what about right before F and B?
Well, how far right before?
Right before.
Yeah.
Right before? What if it was right before?
I mean, that could work too.
What's wrong with that?
So this one is bounded by the limit as x goes to b of f of x. That's the upper boundary, but you never get to that upper boundary. Does that make sense?
Yeah.
So what about this next one? What's the minimum? There is none. What about the maximum? And infinity is a number?
Nope.
Positive infinity.
Positive infinity is
There is-
not a number.
There is no maximum. Infinity is not a number.
Oh,
Why not?
because it's
Don't
not.
tell it that.
All right, what about this one? Does it have a minimum?
Yes.
What's the minimum?
C.
Because of
C.
C.
F of C, not C, but F of C.
Spatial
I
C.
know this.
And what is the maximum?
F of D.
F of D. So,
It's not A.
pardon?
It's not A. It's
H.
Ooh.
Just been Lind. Man,
She's on a roll.
she knows everything.
Lynn does everything.
Lynn's actually Google.
I will stand by that.
Lynn is Google. Thank you, ma'am. So, what kind of a function do we need to have in order to know that we're going to have a minimum and a maximum?
A
closed-
continuous.
A continuous function.
That is, that has a closed interval.
Yeah,
Whoa,
for the
it's
people who are
over
reading
there.
ahead. It has to be continuous and it has to be on a closed interval.
No.
I took a geometry class in college where the professor thought I was a genius because I was always reading one page ahead of him.
So the professor was not genius. What you're
That
saying.
was the conclusion that I came to. He's the same one who took forever to grade our tests, and he said it was because he had narcolepsy, which is it's a real condition.
Yeah, but did he have it?
I think he was just a drunk. I don't think he had narcolepsy. I think he went home, had a fifth of vodka, and fell asleep grading his papers every night.
Oh,
Oops.
poor man.
Not really.
So, if f is continuous on a closed interval from a to b, then f has both a maximum value and a minimum value on the closed interval from a to b. That is the extreme value theorem. Now remember, we did the intermediate value theorem earlier, which said that if a function is continuous on a closed interval from a to b, then f takes on every value between f of a and f of b on that interval. Can't skip over any of them. This is another existence theorem. It guarantees that if you have a closed interval and a continuous function, you're going to have a maximum and you're going to have a minimum. Now, they can occur more than once, but you're going to have a maximum and you're going to have a minimum. All right. So, local extrema. So, f of x has a local minimum at x equals c if f of c is the minimum value of f on some open interval in the domain of f containing c. In other words, what you can do is you can restrict the domain to be something really small. You're just looking in a small neighborhood. Okay? It's a little bit like when you were a kid, there was probably someone who would brag about things, right? I'm the fastest runner in the world, and you'd be like, no, you're not. And eventually, frequently arguments like that end up well, I'm the fastest runner on this block. They are the local maximum, right? If you restrict it enough, then they might be the whatever, fastest, tallest, whatever. But you might have to restrict things an awful lot. Okay? So that's a local minimum or a local maximum. So if we go back to h of x up here, h of b is a local maximum. It is a maximum in some small interval. If you stayed in between a and c, for example, this would be the highest point. So if you can take a restricted domain and it's the highest point in that restricted domain, then it's a local maximum. Now, C is both a local minimum and the absolute minimum. It's the lowest point around it, and it's the lowest point on the entire graph. So it can be both. All right, so for example, in this diagram, what is f of a? It's a local maximum. What about f of b?
Local minimum.
It's a local minimum. And what about f of c? Yeah, it's the absolute maximum. Is it also a local maximum?
Yes.
Yeah, it's also a local maximum. Every absolute maximum or minimum will be a local maximum or minimum. You can't be the fastest runner in the world if you're not the fastest runner on your block. Okay? That idea is going to be helpful to us.
Wait, why isn't like everything a local maximum?
This is a local maximum. It's also the absolute maximum.
No, yeah, but like if you restricted like from B to like halfway to C, like wouldn't every point on that line, like if you made it small enough, be a local maximum?
It has to be an interval.
Oh, okay.
So you can't restrict it to a single point.
Okay.
But yeah, I see what you're saying. All right. So how is this going to involve calculus? Well, first of all, critical points. A number C in the domain of f is called a critical point if either one of these two things happens. If f prime of C is equal to 0 or f prime at C does not exist. Notice we've said that C is in the domain of the function, so that means f of C does exist, but its derivative is either 0 or its derivative does not exist. If you have that, that's called a critical point. Why is it critical? Well, because at that point, your function may change directions. It's a little bit like you pull up to a stop sign. Once you are stopped, is it possible that you could throw it in reverse and go the other direction? Yes. Okay, so your direction could change or your direction could keep going. And you don't know which. One of the things that students tend to overstate is they'll say, well, the derivative was 0, therefore I know I have a change in direction. Not true. Just because you pulled up to a stop sign doesn't mean you're going to start going backwards down the street. Okay? So, find the critical points of this polynomial function. Now, polynomials are pretty easy to deal with. We'll take the derivative, which will be 3x squared minus 18x plus 24, and set that equal to 0. Is there any point where this new polynomial function doesn't exist? No, polynomial functions are defined for all real numbers. So I'll factor out a 3. So this will be 3 times x minus 4 times x minus 2 is equal to 0. So either x equals 4 or x is equal to 2. These are my critical points. So how about for this one? Find the critical points of f of x is equal to the absolute value of x. What's the critical point for that?
0.
Yeah, x equals 0. Because the derivative doesn't exist at that point. By the way, if you wanted to show that non-graphically, what you would have to do is say that f of x is equal to the opposite of x for x less than or equal to 0, and x for x greater than 0. Then you could show that the left-hand derivative and the right-hand derivative don't agree with one another. But it's easier to think about it graphically. So Fermat's theorem says that if f of c is a local minimum or a local maximum, then c must be a critical point of f of x. Okay, now, be careful. The converse of this is not true. This is part of why we talk about converses in honors geometry. The converse of this is not true. Just because you have a critical point doesn't mean you have a local minimum or a local maximum. You have the opportunity to have one, but you're not guaranteed one. So, for example, this is my hand-drawn sketch of y equals x to the fourth minus 3x cubed. Here we have a critical point at 2, which is a local maximum, but at 0, there's a critical point that is neither a local maximum nor a local minimum. By the way, the reason you know that is because if you factor an x cubed out of this, this has a single root at x equals 3. Remember, a single root is where the graph will look like a line as it passes through the axis. What do you have here?
I don't know the name of it, but it looks like the origin.
You have a triple root at x equals 0. Y'all did these last year, right?
Yeah.
Yes.
So at a triple root, it flattens out and then goes back up again. Okay, let's move on. Page 4. So, extreme values on a closed interval. This is frequently in other textbooks. Your book never calls it this, but at the College Board, everybody calls it this. It's called the candidate's test. And what it says is that if f of x is continuous on the closed interval from a to b, let's stop there. If it's continuous on the closed interval from a to b, what are we guaranteed is going to happen? It's going to have a minimum and it's going to have a maximum. That's the extreme value theorem. And f of c is the minimum or maximum value of f on the closed interval from a to b. Then c is either a critical point or one of the endpoints. The only places where you can have maximums or minimums are going to be at critical points or at endpoints if you have a continuous function on a closed interval. And you're going to have a maximum and you're going to have a minimum. So let's do a couple of these. Find the extrema of f of x equals 2x cubed minus 15x squared plus 24x plus 7 on the closed interval from 0 to 6. So we already have two possibilities, f of 0 and f of 6. We need to see, are there other candidates? So to find those, I need to find the critical points. F prime of x, which will be 6x squared minus 30x plus 24. Set that equal to 0. I'll factor out a 3. We'll have 2x squared minus 10x plus 8 equals 0. Let's see. Does that factor nicely? Oh, why didn't I factor out a 6? That would have been nicer, wouldn't it? So it's 6 times x minus 4 times x minus 1. So x equals 4 and x equals 1. So I have critical points at x equals 1 and x equals 4. So my candidates for the maximum are and minimum are f of 0, f of 6, f of 4, and f of 1. Those are the only places that it can happen. So basically what I'm going to do is I'm going to see, well, which one's bigger, which one's smaller. So we'll do x and f of x. And it could happen at 0, or at 6, or at 4, or at 1. 0, fortunately, is pretty easy to calculate. 1 is pretty easy. Negative 13, that's 11, plus 7 is 18. And then after that, I'm going to reach for a calculator because, well, that just looks horrible. So quit out of that. 2 times 6 raised to the third minus 15 times 6 squared plus 24 times 6 plus 7. I got 43. Someone verify that for me. Pardon? You also got 43? Well, if Lynn got it, I must be right. And then at 4, I got negative 9. Okay? So the maximum is f of 6, which is 43. And the minimum is f of 4, which is negative 9. So we identified who's a candidate, and then we just counted the votes, basically. Right? Who got the most votes? Who got negative votes? Okay, the analogy kind of breaks down, down there, but you get the idea. All right, let's do the same thing for this one. This one's not a nice polynomial function. Let's take the derivative of this, f prime of x. And again, I already have 2 candidates identified. Is this a continuous function? Well, there's nothing in the denominator, and I'm taking cube roots. I can take cube roots of basically any real number. So yeah, we're good to go. So the derivative is going to be negative 2/3 times x minus 1 to the negative 1/3. Which, if I rewrite that, that's 2 over 3 times the cube root of x minus 1. Is that ever going to be equal to 0? I'm sorry? It's negative 2. Thank you. Not that it matters actually for the problem, but thank you. Is that ever 0? No, it's never 0. Because the numerator is always negative 2. Remember, the numerator determines if something's 0 or not. That never happens. But f prime of x is undefined. At
X equals 1.
x equals 1. You were just a woman ahead of her time. So I have 3 candidates. Negative 1, 2, and 1. At negative 1, I have no idea what that is. 1 minus negative 2 to the 2/3 power? Eek. Oh, that's horrible. Negative 2.587. Remember, please, 3 decimal places minimum. And at 2, that's going to be 1, so that's going to be 0. And at 1, this is going to be 1. Well, at least that was easier. So your minimum is f of -1, which is -2.587. And your maximum is f of 1, which is 1. We must be getting near the end.
This is the last one.
Excellent. So find the minimum and maximum of f of x is equal to sine x plus cosine squared x on the closed interval from 0 to 2 pi. So it's a closed interval. And is this a continuous function? Yes, if those two things happen, and you have to always think about that, if it's continuous on a closed interval, then we will have a maximum, we will have a minimum, and the candidate's rule applies.
What do you write if you don't? Just not closed interval, min or max?
Well, if it's not a closed interval, then we have to do something else. But you can't use the candidate's test if it's not a closed interval.
Okay.
Okay? There may be a min or a max. You just can't know by the candidate's test. It's a great question. So then f prime of x is going to be cosine x plus 2 cosine x times negative sine x. And I want that to be equal to 0. And this is one that we could do by hand. Frequently, when you get ones like this, you can't find those zeros by hand. You'd have to use a calculator. But here I can factor out a cosine x. I have cosine x times 1 minus 2 sine x is equal to 0. So that's going to occur either where cosine of x is equal to 0 or 1 minus 2 sine of x is equal to 0, which would mean that sine of x would have to be 1/2, right? And now you get to dazzle me with your brilliance at the unit circle again. Where is cosine equal to 0?
Yikes.
Oh, God. Pi over 2 and
Oh.
Negative pi over
Negative
2.
pi over
that's not negative pi over 2 is not on the interval.
It could be.
What's coterminal with negative pi over 2?
3 pi over 2.
3 pi over 2. And then where is sine equal to 1/2?
Pi over 3.
Yeah.
Power 6.
Yo, unit circle school.
Pi over 6.
Never mind.
And also,
Just -2. No, -5.
that's not in my interval.
Like 5 pi over 6.
Yep. And it's not negative 5 pi over 6 anyway. It'd be negative 7 pi over 6. But it'd be 5 pi over 6.
Mr. Hedgerow would be so disappointed.
Yeah.
So we have 6 candidates.
That's a lot.
It is a lot.
We cancel some out.
We just decide we don't.
I don't like your Twitter. Cancel.
Oh.
Wow. I don't know that functions have Twitter, but okay. So I've got 0, 2 pi, pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. In the interest of time, I'm going to use a calculator to do all these. Clear that and the function was sine x plus cosine squared x. So sine x plus cosine of x times cosine of x. And I'm on the interval from 0 to 2 pi. And graph. Probably should have restricted my y sum also, huh?
Is it still at 50?
So let's change my window here
Yeah.
to something a lot smaller. Say -2 to 2.
5.
Wi-Fi.
No.
Oh, much nicer. So what's happening here?
One of them's negative.
What do you have here?
Oh, it's so
A local minimum, but not the absolute minimum. Okay, so if we trace this to 0, we get 1. If we trace this to 2 pi, oh, it doesn't like that. Did I not make my window big enough? Now let's go to 7. They're taking the table down from earlier. All right, so 2 pi. I don't know why it didn't like going to that. It should have. Not really surprising that that's 1. At pi over 2, that's that little local minimum of 1.571. At 3 pi over 2, oops, not that. Trace this to 3 pi over 2. There's that local minimum, which is also the absolute minimum. At pi over 6, that's got to be this, doesn't it? That little local maximum, which is also the maximum. So pi divided by 6. 1.25. And then at 5 pi over 6, bet it's the same thing. Not 3, 6. Yep, 1.25.
Can't do pi over 2 again?
It's 1. It's not 1.57.
Pardon? Why pi over 2? Did I skip it?
No, I think you wrote down what X
You were-
was for and
you
so
watched
Y.
You didn't-
Oh, I wrote down the, sorry, my fault. So this is 1.25. So let me finish this up. The max is 1.25. Let's trace this to pi over 2. Oh, y is equal to 1 at that point. So the maximum is 1.25 and the minimum is -1. Yes. Yes. All right, let's go ahead and